Okay, so you have to excuse me there. I ran over, got too excited talking about Margaret Thatcher. She was actually the Prime Minister when I was a teenager, so it's kind of a weird memory. As we mentioned, she was the only Prime Minister in British history to have a bachelor's in chemistry, and it turns out she's a bit of a trailblazer in that regard because, believe it or not, Angela Merkel, the now Chancellor of Germany, also has actually a master's degree in chemistry, so that's kind of cool. And also, not a politician, well, kind of, I guess, but not really, is Pope Francis. Pope Francis also has a master's degree in, I think, environmental science or something. So, you know, some pretty effective world leaders are chemists. All right, so there's hope for you yet. If you don't become an actual chemist, there's other things you can do. All right, so moving on. This one here, I have that same question we had before, the disproportionation of iron 2 to iron and iron 3 plus, okay? In this process, I want us to work out delta G, okay? So we're going to use Faraday's equation, all right? Just so I can remind myself of that real quick. So delta G equals minus NF E. Now the little plimsoll means standard, right? Okay. Now, when we look at this process, we're looking at the transfer of 2 electrons and then 2 of 1 electron. So n equals 2. So in this equation, n is the number of electrons in the process. F is the Faraday constant, as we mentioned. E is the potential. For that one, we just worked it out in the previous example a couple of pages ago. That's the 1.22 is the voltage of that cell. So nice and easy. Delta G equals minus 2 times 96,500. That's the relation between charge and moles. I like to put, you know, the charge in there. 2.34 times 10 to the 5. Now units. Current times voltage is basically energy, right? So that's joules, all right, per mole. Take that down by minus in front. 234 kilojoules per mole minus. Okay, is it spontaneous? Yes, because it's a negative number for delta G. So remember, if delta G is minus delta G, if you have a flashback and think about it, delta G is that thing that relates first and second laws of thermodynamics, you know, entropy and enthalpy. So when delta G is minus, it's a spontaneous favorable process. Okay, so yeah, it's minus, so it's spontaneous. Now, when you have a battery, eventually it goes flat, right? What does that mean? It means the reaction has kind of stopped, if you wish. Well, it hasn't really. We know that reactions just don't stop. They actually attain equilibrium. So when a battery goes flat, it's actually in equilibrium. You've got a fixed number of reactants and products. There is dynamic exchange between the two, but there's no net motion in one direction, so there's no current, essentially no electrical current, right? So a flat battery is a battery in equilibrium, okay? And then when we have that, we can slightly modify our equations to kind of put in this Q situation. So Q is, you remember, it's kind of same as equilibrium constant K, but under non-equilibrium conditions. So this is true for any condition. That would be K for a flat battery, okay? So we have a slight modification. This is the Nernst equation. Based on the ratio of products to reactants, we see a modification of G, right? Or modification of voltage. And this is an interesting thing because if you remember, when we use 0.1 mole per liter concentrations for that zinc copper battery, the classic Duracell, we worked it out to be 1.1 earlier in the packet. But in real life, it's actually 1.5 if you look at this actual battery, right? And that's because this value here, there's it's a top-heavy ratio, right? So there's more products than reactants, I guess, in the LNQ there, okay? So there's probably actually more reactants than products because there's a minus. Okay, so this Q factor will modify the voltage of the system based on concentrations of reactants and products. Okay, so that's why, you know, you don't get 1.1 here, you get 1.5. Concentrations are higher. Okay, that's called the Nernst equation. All right, so final wrap up. And what I want you to do is try this one. Okay, try this one. All right, I'm feeling generous, a little bit of extra credit. So if you do this before, let's put the... I'm a total nerd, right? May the 4th be with you. Star Wars Day. If you give me this before Star Wars Day, I'll give you a couple of points of extra credit. Okay, let's talk you through it. Right. So when you work this through, as I mentioned, you know, K is kind of the last kind of stop for a battery. When you get a flat battery, it's in equilibrium. So when delta G is 0, there's no power coming out of the battery. This is true. Okay, so minus delta G equals minus RT ln K, right? So we can use this equation to find K. All right. Now here's the plan. All right. What I want you guys to do is look at this equation here. Use your new equation, this one, to answer the following question. What is the value of the equilibrium constant? I'll give you a plan, right? You can find delta G using minus NFE. All right. And so N will be 2, and it's the nickel, 2 and 0, iron 2 and 0 system. You can look on the table for the standard electrode potentials, find the difference. That'll be E, Faraday that, delta G, right? And then you know that delta G equals minus RT ln K, rearrange for K, and you can actually find the value of K. Okay, now remember, that's got to be in joules per mole. So you'll probably get an answer in kilojoules. Oh, I'll put that up for you. Make sure that, you know, because you got R, right? So remember when we did like various things like the Arrhenius equation and things like that, R is 8.31 joules per mole per Kelvin. So this has to be in joules, not kilojoules, okay? So be careful. All right, get a value for K. If you get the right answer, I will give you a couple of points of extra credit. Give you kind of a hint, okay? Something to a larger power, right? So it's going to be something times 10 to the larger number, 5, 6, 7, somewhere up there, okay? So somewhere in the hundreds of thousands to tens of millions, somewhere between 10 to the 5, 10 to the 7 as an answer. Okay, if you get that before Star Wars Day, send it to me. It's just, you know, just take a picture with your phone, send it to me and you're good. Okay, so stop there. I'll post this. Any questions, again, please post them in the discussion area below. And the next packet will be our last packet, which will be nuclear chemistry. I'll see you then.